Good morning. We're going to start with the third module, energy systems. Under that, chemical fuels. What do you mean by fuels? Fuels. As soon as we think about fuels, the first thing which comes in our mind is it might be wood or petrol or kerosene or LPG, isn't it? So, what is the definition of a fuel? Is fuel confined only to these four things? Might be this petrol, diesel, LPG and wood? Or what is the definition of a fuel? Can we call a fan as a fuel or a plastic as a fuel, or can you call the cloth as a fuel? If we define a fuel as a substance which ignite as soon as we ignite with a lighter or a matchbox, if it ignites, so can we call it as a fuel? So when a cloth or a cotton ignites, can we call it as a fuel? No. So fuels or a chemical fuel is defined as a substance which contains carbon and hydrogen as its main constituents and produces significant amount of light and heat on combustion. So any substance which contains mainly carbon and hydrogen, when it contains mainly carbon and hydrogen as its main constituents and produces significant amount of light and heat and combustion are called as what? Chemical fuels. For instance, you can take wood. So wood is made up of plant. So plant contains what? Carbon and hydrogen itself and traces of oxygen and also nitrogen. But mainly it contains what? Carbon and hydrogen. So when you ignite, so combustion means in presence of oxygen. So when this undergoes combustion, so what happens? So it liberates carbon dioxide, water and energy. So energy, it might be in the form of light, or energy it might be form of heat. So energy have different forms, right? Light energy, heat energy, etc. But here energy we consider in the form of heat itself. So you can take your tire, right? Your automobile tire. When it ignites, so but it does not produce a significant amount of heat. So it contains major quantity of sulfur, but does not produces, it ignites, right? It produces so much amount of light. That is, it ignites and produces so much amount of light, but does not produces heat and produces smoke, right? So that cannot be considered as a fuel. So major thing is it should contain mainly carbon and hydrogen, traces of oxygen and any other things, but on combustion it produces significant amount of light and heat energy. So what are the examples? It might be wood, it might be coal, charcoal, petrol, diesel, kerosene, etc. Any of our fossil fuels. So now let us see the classification of our fuels. So fuels are classified into two types depending upon their physical state and depending on occurrence. So depending on physical state. So what do you mean by physical state? So how they appear. So depending upon the appearance, right? So depending upon the appearance, so as soon as you look some kids, we can make out they are either male, a boy or a girl, right? So similarly, depending upon the physical state, so how they look, the fuels are classified further into three types. So what are those? Solid fuels, liquid fuels and gaseous fuels. So what are the examples for this? So solid fuels example, wood, coal, charcoal, etc. So wood, everyone knows what is wood. Now what is coal? So coal, when wood is buried under the earth, right? So what happens? After years together, it undergo, so not only wood, so if you take any of the plant bodies or human bodies, when it is buried under the earth, so it undergoes anaerobic degradation under high temperature and pressure. So the carbon and hydrogen gets converted into the form of coal. So this is used in the thermal power generation, right? So what is charcoal then? So charcoal, so if you take the wood, okay, so this wood, when it undergoes combustion, so you can it undergoes combustion, the remains of wood after combustion, the small pieces, that is called as charcoal. This charcoal, you might have seen, it is used in for pressing clothes. So nowadays it is replaced by electric iron box, but still, so if you go to rural places, they are going to use this charcoal for pressing the clothes. So liquids, liquid fuel, your petrol, diesel, kerosene, etc. Gaseous, so it might be LPG, compressed natural gas, natural gas. These are the example of our gaseous fuel. So next type of fuel, based on the occurrence, where it is occurring. So based on occurrence, you have two types of fuels. They are primary fuels and secondary fuels. So what do you mean by what do you understand by primary fuels? So all naturally occurring fuels are called as primary fuels. So it might be wood, it might be coal, it might be crude petroleum oil. All these occurs naturally. So irrespective of the state, we can classify them as primary fuels. So wood is a solid fuel, your crude petroleum is a liquid fuel, natural gas is a gaseous fuel, right? So irrespective of the state, okay, so these are classified as primary fuels. So all naturally occurring fuels are called as primary fuels. So wood, your crude petroleum oil, coal, so all this comes under primary fuels. So it is shown there very clearly, right? So coal is also present there. So next, secondary fuels. So what do you understand by secondary fuels? So the primary fuels which are is obtained after, if it is processed. So these fuels, whatever we call secondary fuels, are derived from primary fuels. These are derived from primary fuels. Example, here charcoal. So how is charcoal obtained? We're going to subject wood for combustion, right? So it undergoes what? Combustion, right? So after combustion we get remains of wood, that is called as charcoal. So crude petroleum oil is subjected to fractional distillation. When this crude petroleum oil is subjected to fractional distillation, depending upon temperature, petrol, diesel and kerosene will be separated. So here some chemical process is done in order to get the fuel. So that petrol, diesel and kerosene are called as what? Secondary fuels. Here LPG, once again it is a secondary fuel. CNG, compressed natural gas, it is a secondary fuel. So once we get the fuel, we are supposed to measure what its performance. So the performance of this the fuel is measured by its calorific value. So let us see what is this calorific value later. Okay, so here the diagrammatic representation of the fuel is classification of fuel is given very clearly. So fuels are classified into primary fuels, secondary fuels. So primary fuels, solid, wood, peat, liquid, it is crude oil, gas, natural. So it is examples of your fuel, primary and secondary fuels. So secondary fuels example, solid, it is coke, charcoal. Secondary fuels, it is petrol, LPG, gaseous, coal, gas and water gas. So let us see what is calorific value. So it is defined as amount of heat liberated when a unit mass of fuel is completely burnt in excess of air or oxygen. So calorific value is defined as amount of heat liberated when a unit mass. What do you understand by unit mass? It might be 1 milligram or 1 gram. It should be only 1. So when a unit mass of fuel is burnt completely. Burnt completely means, so it should burn completely. You're not supposed to have any residues there. So if the fuel should burn completely, what should be given? You are supposed to supply sufficient quantity of oxygen. So for 1 gram of oxygen, how much, for 1 gram of fuel, how much oxygen is required to burn completely? We don't know, isn't it? Therefore, we are going to supply excess oxygen or excess air. So how much ever oxygen is required, so much oxygen will be utilized by the fuel and remaining will be as it is. That is the reason excess air or excess oxygen. Okay. So I repeat, the amount of heat liberated when a unit mass of fuel is completely burnt in excess of air or oxygen is known as calorific value. So here you have two types of calorific values. They are gross calorific value and net calorific value. So what is gross calorific value? So gross calorific value. So the amount of heat liberated when a unit mass of fuel is burnt completely in excess of air or oxygen, and the products of combustion are cooled to room temperature. So what are the products of combustion? The products of combustion, it might be carbon dioxide and water. So carbon dioxide will be let off into the atmosphere, whereas water, that is steam, will be cooled to room temperature. So when steam is cooled to room temperature, some amount of energy will be liberated. For instance, for 1 gram of water vapor when it is cooled, so it liberates 587 calories per gram of heat. So that heat also will be considered. So that means products of combustion are cooled to room temperature. Means when water vapor is cooled to room temperature, the heat liberated by water or steam, when that will be calculated in your GCV. Next, coming to NCV. So the amount of heat liberated when a unit mass of fuel is completely burnt in excess of air or oxygen, and the products of combustion are let off into the atmosphere. Let off into atmosphere means here the products, we are going to worry only about the amount of heat liberated by fuel, but not anything else other than it is. We are not worried about the amount of heat liberated by water or anything else. So we are worried only about the heat liberated by fuel. That is your NCV. So let us see how to calculate this GCV or NCV of a fuel or solid fuel or liquid fuel in our next session. So using bomb calorimeter. So thank you.